See on the target 14 test on factoring polynomials completely. So probably the biggest challenge for that is deciding which pattern or which method to use. So this one, if you look at something and you say, hey, wait a minute, if that were an a squared or some number squared instead of x to the fourth, I'd know how to factor that. That's the difference of two squares. Square root the 25a squared, square root the 3 to get the 5a and the 3. And then there's going to be one with a plus, one with a minus to cancel the outer and inner, so there's no middle term, there's no a term. So if I were factoring one with x to the fourth instead, then I would just have 5x squared plus 3 and 5x squared minus 3. Because when I multiply my first together, 5x squared times 5x squared is going to give me 25x to the fourth. And then, of course, you always check to make sure it can't be factored anymore, which that one can't. Those quadratics aren't perfect squares or anything like that. If it's a cube, then you should remember the difference in sum of two perfect cubes. So if I cube root 8x cubed, the cube root of 8 is 2, and the cube root of x cubed is x. Because 2x times 2x times 2x is 8x cubed. Likewise, the cube root of 64 is 4, because 4 times 4 times 4 is 64. So when you factor the difference of two cubes, the first factor is going to be a binomial with the difference of those cube roots. The second factor is going to be a trinomial where you square those values. So if I square the 2x, I'll get 4x squared. Then squaring the 2 and the x. It's going to end with the other number squared. 4 squared is 16. In the middle, it's going to have a term where you multiply those two together. The 2x times 4 gives you the 8x. And then these are both going to be plus signs. If the question was factor 8x cubed plus 64, it'd be exactly the same, except this would be a plus, and the minus would be with the 8x. So now part C kind of combines both of those ideas. This is a little bit of a challenge problem here, but this is a perfect cube. The cube root of 27x to the 15th, cube root of 27 is 3, and the cube root of x to the 15th is x to the 5th. Because x to the 5th times itself 3 times, you'd add these exponents, and you get x to the 15th. And then you'd have minus 5 would be the cube root of 125. So I cube root both of those, that's my binomial, and then my trinomial, I square the first term, so square 3. When I square x to the 5th, you do power to a power, you'd multiply. X to the 5th squared, you'd multiply the 5 and the 2. The 5 squared at the end is going to be the 25, and then in the middle I multiply those. 3x to the 5th times 5 is 15x to the 5th. So now, for the last one on this page, factor this using the box method. So this is a plain old quadratic. So the box method would say to put the first and the last terms in the corner, and then you have to answer what I call the magic question. You find two things that multiply to the product of the first and last, which would be negative 54x squared, and add to the middle term, the negative 3x. So you might start making a list of factors of 54 and come across negative 9x and positive 6x. They multiply to negative 54, and they add to negative 3. So I'm going to put those in my other two corners. So now I have the 4 terms in there. So now I can factor out the GCF from each row and each column. Something's not quite right. Oh, actually it will work. You know what I did? I forgot the number one rule. Before you do something like that, you should factor out the GCF. I forgot to factor out my 3 first. So let's see if it works out when we do this. So it kind of works out, but you end up factoring if you factor out the 3 from both of these, you'll get the factorization. The correct answer is 3 times x plus 1 times 2x minus 3. But I don't have both 3's in my answer. You could check that with multiplying. I'll real quickly show that box method with the 2x squared minus 1x minus 3, two things that multiply to negative 6 and add to negative 1 are negative 3x and 2x. So now I can factor out my GCFs, and you can see where I get the 2x minus 3 and the x plus 1. And that 3 that we factored out leads in front of that. So that's really factor by grouping, because if you wanted to take this and factor it by grouping, you'd need to rewrite it with 4 terms. And that's where the minus 3x and the plus 2x, that's equivalent to the minus 1x comes in. It's just writing that trinomial a longer way with 4 terms. And then you look at the first 2, take out the GCF. Look at the second 2, take out the GCF. Only GCF of that is a 1. So you can see we have a common factor of 2x minus 3. So if we factor that out, we'd be left with x plus 1. And again, of course, that 3 that we factored out first would have to stay in front. So the box method really is factor by grouping. Now on the next page, I'll not forget the cardinal rule here. First, factor out any GCFs. So I look at this one, I can factor out a 4y squared from everything. If I divide each of these by 4y squared, I'll get y to the 4th plus 3y squared minus 4. And then once you've done that, then try to factor what's left. So I recognize that what's left is a 4th degree, but it's in quadratic form because 4, that exponent of 4 is twice the exponent of 2. So normally if I had a quadratic with a y squared, I'd factor it with a y and a y. Well, if I have a y to the 4th, I'm going to factor it with a y squared and a y squared. The leading coefficient's 1, so to factor this as if it's a quadratic, I just find what multiplies to negative 4 and adds to 3. And that would be 4 and negative 1. Now this is good work to get to this point, but it's actually still not done because this part is a quadratic that can be factored. It's the difference of 2 squares. So that would factor to y plus 1 times y minus 1. And then we'd still have the y squared plus 4 and the 4y squared. So there's all the factors that you can get out of it. So kind of taking the same first approach for this one, I'm first going to factor out the GCF, which in this case is going to be negative 6x cubed. I'm left with x squared minus 2x minus 24. Notice I factored the negative out. Usually that's better, so then what you're left with has a positive 1 for a leading coefficient, or a positive leading coefficient. Makes things easier. And then this time we do have a quadratic left, so we just factor what's left, find 2 things that multiply to negative 24 and add to 2. So this is the complete factorization for the second one. Now the third one does not have any GCFs. And it's not in quadratic form. However, I can use factor by grouping, and a clue for that is it has 4 terms. So you could either take the GCF out of the first two, take the GCF out of the second two, and then you notice you have a common factor of h plus 4 among both of those. So if you factor that out, you're left with h squared plus 2. That's your second factor. If you don't like doing it that way, you can use the box method to factor by grouping. Just put your 4 terms inside, take out the GCF of each row and each column, and there's your 2 factors, h plus 4 and h squared plus 2. Now where we're going with this, that kind of ties this together with target 15, is how it relates to a function. And this is kind of just a little bonus question. I know I didn't give this one to you. But if you're given some points and you're asked to write a cubic function which has an x cubed in it that passes through these points, these are zeros. So if you know you have zeros, then you can identify some factors. Now this is not a 0, this one's the y-intercept. The zeros are the x-intercept. So if you wanted to determine what the graph would look like, what you would do is just multiply x plus 1 times x plus 4 times x plus 6, distribute that out, and see which of these you get. And right away I know if I put 0 in I should get 24, not negative 24, so I know it can't be these. So it's going to be one of these two. So we'll be talking more about that next week. Questions. There's a lot going on in this one. Hallie?
Okay, I have a couple questions.
Yep.
So the first